In solving question 2C.2, question 4, part D, you're asked to find the gradient of the tangent to the function y equals 6 times cube root of 1 minus 2x when x equals 0. I recommend that you immediately write down the function with fractional powers. So here's the function again, y equals 6, and instead of cube root, we're going to write to the power 1/3, 1 minus 2x to the fractional power 1/3. As soon as you see that you need to find the gradient of the tangent at a point, we think, well, the first derivative gives us gradient. So I'm going to find dy dx, and you've been practicing the chain rule. I'm going to do the chain rule in my head, which some of you may not be ready for yet. So just listen carefully. The 6 is just a constant out the front. When I do the derivative of the function 1 minus 2x, I'm just going to hold that number as like the u function without writing it down, and it's to the power 1/3. So I'm going to differentiate. So I bring the 1/3 down and I put it in brackets so I know I multiply. I haven't done anything to the function at this stage, and I'm taking 1 from the power. So 1/3 take 1 is minus 2/3. And then the last step is to find the derivative of the u function 1 minus 2x. So I'm doing all of this in my head. The derivative of 1 minus 2x is just minus 2. And I'm multiplying it by minus 2. So let's just write that a bit more neatly. 6 times 1/3 is positive 2. Positive 2 times negative 2 is negative 4. And so I'm just rewriting 1 minus 2x to the minus 2/3. And I think, but the gradient is at x equals 0. So if I put in 0 for x, that will be minus 4 times 1 minus 0 is 1, and 1 to any power is 1. But you might like to be reassured. So let's put a positive 1 to the minus 2/3 in my working column is 1 over 1 to the positive 2/3. 1 to the positive 2/3 means 1 squared followed by cube root. So 1 squared is 1, and cube root of 1 is also 1. So that is why when I just see 1 to the minus 2/3, I know that the answer is 1. So 1 times minus 4 is minus 4. And that is the gradient of the tangent.